Good day, class. Welcome to our topic for the day, which is entitled Set, Relations, and Function. So this is under our first module in Discrete Structures 2. And to start with, we have on the board the first operation on set, which is referred to as union, which is represented by the symbol U. And we have the given, the set A and the set B. Set A is represented by the elements A, B, C, and D. And set B is represented by the elements E, D, F, G, and C. So what we're going to do now is to get the elements of the union of A and B. So what we're going to do is write A and the symbol of union, write B, and then the equal sign, the open brace, and then after that, write the elements that are unique. But at first, you can also write all the elements that are present in A and present in B. So let's just first write the elements that are present in A. That's A, B, C, D, and write the elements that are present in B. Those are E, D, F, G, and C. And enclose it with our close brace. And as you observe, the elements A, B, C, D, E, D, F, G, C, there are elements that are repeated. So what are we going to do if there are repeated elements? We can just simply cancel those elements that are repeated. So we can cancel D. So since D is already here, so cancel this letter D. And since C is here already, so we can cancel the other one, that is C. And then rewrite the final elements which are unique. So those are the elements A, B, C, D, E, F, and G. So now, we derive the elements of the union of set A and set B. So this is our final answer. So this is the union of A and B. We will now proceed to our next operation, and the next operation is intersection. So what is the symbol for intersection? The symbol for intersection is the inverted U. So intersection is defined as the elements that are present on both sets. So we have here the set A and the set B. A is represented by the elements A, B, C, and D, while B is represented by the elements E, D, F, G, and C. So our objective here is to see what are the elements that are in A and that are in B, meaning they are common elements of A and B. So as we observe, A is unique in A, B is unique in A, C is present in B, therefore, it is one of the intersection of set A and set B. And the other is D, which is also present in B. So C and D, these are the intersection of set A and set B. So how are we going to write it? So first, write the name of the set. So that is A and B. And then write the symbol in between. So the symbol is the inverted U. And then after that, rewrite the elements that are common in A and B. So as we've said a while ago, C is common in A, C is also common in B. Therefore, you write C as one of the elements of our intersection. Another element that is common in A and B is D. So have a comma and write D and enclose it with the close parenthesis. So we have the intersection of A and B, that is the elements C and D. next operation that we will be discussing is the difference of sets. Given our sets A and sets B. Set A has the elements 1, 2, 3, 4, 5, and B has the elements 0, 2, 4, 6, and 8. So what we're going to do is get the difference of A and B. So in order for us to know what is the difference between A and B, so we simply write all the elements that are not in B. So what are the elements of A that are not in B? So those are 1, 3, and 5. So the elements of the difference between A and B is 1, 3, and 5. So 1, 3, and 5. So in order for us to determine the difference between B and A, so the same thing goes. So what are the elements of B that are not in A? So the elements of B that are not in A are, those are 0, 6, and 8. So that is how we compute for the difference of sets. The next operation is the complement of a set. So again, given on the board are sets A and set B. So for set A, we have 1, 2, 3, 4, 5. And for set B, we have 0, 2, 4, 6, and 8. So first, we need to have the universal set. What are we going to do in order for us to have the universal set? So that is by combining the elements of A and the elements of B. So simply rewrite the elements that are in A and in B, disregarding the repeated elements. So we will just write those repeated elements once. So we have 1, 2, 3, 4, and 5 as the elements of A, and we have 0. We have, since 2 is already here and 4 is already here, we are just going to write 6 and 8. Followed? So, if you wanted to rewrite it in unordered way, so you can just rewrite U is equal to, write 0, 1, 2, 3, 4, 5, 6, and 8. So, these are the elements of the universal set. So, how are we going to get the complement of A? Complement of A is written like this. So you have a dash above the letter A. So what are the complement of A with respect to the universal set? So complement of A with respect to the universal set is or are the elements that are not in A. So you'll just evaluate which amongst these elements are not in A. So obviously, we have 1 in A, 2, we have 3, we have 4, and we have 5. So, what are the elements of the universal set that are not in A? So, those are 0, 6, and 8. So, our complement of A, or also referred to as A prime, is 0, 6, and 8. So, that same process will be used in order for us to determine the complement of B. So it is always with respect to our universal set. So what are the elements of the universal set that is not in B? So you'll just evaluate our given. So B, it has 0, 2, 4, 6, and 8. So what are those elements of the universal set that are not in B? So those are, again, those are 1, 3, and 5. So this is the complement of B with respect to our universal set. So that is how we determine the complement of a set.